Welcome to this guided practice on enthalpy of solution. We're going to take a look at a problem today with multiple steps. And this is about how the energy can change when we actually are forming a solution, so the process of that solution forming. So we're given this prompt that 10 grams of sodium carbonate was placed in a coffee cup calorimeter with 90 milliliters of 25 degrees Celsius water. The temperature of the solution changed to 19 degrees Celsius. Assuming the specific heat of the solution is 4.18 joules per gram degree Celsius and solution density is 1 gram per milliliter, determine each of the following. Anywhere along this you can pause and try it yourself and then play and see how you did. So let's get started with a couple things. Before we even start discussing some of the problems, I want to look for a couple cues. So one thing is I was given the solution density of 1 gram per milliliter, and I noticed I was given water. The amount of water that was added as 90 milliliters. And so that's actually, the density of water is approximately 1 gram per milliliter at 25 degrees Celsius. And so what I can do is I can say, okay, well, if I have 90 milliliters of water, and for every 1 milliliter, it would be equivalent to 1 gram, and so I can actually say that this was the same as 90 grams of water. And so whenever you're given the amount in milliliters of water, we can actually do that and make that assumption when we're solving these on paper or digitally. So the first question asks, is the solution endothermic or exothermic? And then it asks us to justify our answer. So let's take a look at what happened to the temperature. Okay, so the temperature went from 25 degrees Celsius water to 19 degrees Celsius water. And so what we know is that the water, okay, so the water is decreasing temperature. So I'm just going to write what I noticed first, okay? And the water is decreasing temperature because the process of the solution forming is actually absorbing that heat from water. So I can say because the solution forming process is absorbing heat from the water. And any process that's absorbing heat, okay, so processes that absorb heat are endothermic. So that's always something we have to be kind of careful with, is thinking about the fact that the water is the nearest surroundings and the process is exchanging heat with that water, even as a solution is forming. Even though the water is part of the solution formation process is actually endothermic in this case. And so then the next thing it asks us, what is the enthalpy of solution in joules? And so in order to solve this, we're going to use our Q equals Cm delta T. And we're going to solve this for water and then compare it. So Q of the water, which is what we're measuring really the temperature of, we're going to use the specific heat of 4.18 joules per gram degree Celsius. So this is Q equals Cm delta T. We know that our mass, and our mass has to be the total. So we have 90 grams of water and 10 grams. So the solution is a total of 100 grams of solution. Okay, so total mass there. And then we're going to do our temperature. So Final temperature was 19 degrees Celsius. Initial temperature was 25 degrees Celsius. Okay. And when I calculate all of that, I get negative 2508 with sig figs. We actually had 3 significant digits in each one of our data points to begin with that are up in the prompt, so we should actually have 3. It's hard to get that, so it should be negative 2510 joules. Okay, so that's for water, but that's not what we're looking for overall. What we want to know is what was the heat for the process or the solution. So Q of the water is equal to the negative Q of the solution process or solution formation, and so that means that the Q of the solution would be a positive value for enthalpy, so it would be 2510 joules. Okay. So the next question asks us, what is the molar enthalpy? And so with molar enthalpy, what we want to know is how many moles of this substance did we have to begin with first? And so there's kind of a process to solving these. So the first thing I want to do is I'm going to convert joules to kilojoules. So you can divide by 1,000, or we can say 2,500 joules. There's 1,000 joules in 1 kilojoule. And we can show the conversion too. Either way works. So we get 2.51 joules. Okay. The second thing that we're going to do is we are going to convert grams to moles of the solute, the thing that's being dissolved. We're going to use molar mass. Of the sodium carbonate, Na2CO3. Okay. And so we're going to take that 10 grams that we started with. I went ahead and calculated the molar mass already ahead of time, and it was 106 grams per 1 mole. Okay. And so we get 0.0943 moles. Now all we need to do is divide the kilojoules by the moles. That's the last step in this. So now we're going to, for number 3, divide kilojoules by moles. So we're going to take our 2.51 kilojoules. We're going to divide that by the 0.0943 moles. To double check this calculation really quick. 2.51 divided by 0.0943, and I get 26.6, so 26.6 kilojoules per mole. Now the nice thing about having molar enthalpy is no matter what, we always know per mole, that's what we get. So if we were given something like part D that says, hey, now you have 2.3 moles, how much enthalpy would that be? Now we can just do a quick conversion. So in this particular situation, we can start off with our 2.3 moles, so 2.3 moles. If we were given grams, we would just, again, use molar mass to convert from grams to moles. So 2.3 moles. We know that for every 1 mole, there was 26.6 kilojoules. So 2.3 times 26.6, and we get 62 sig figs in that, so we'll round to 2 sig figs, so 61 kilojoules if we started with 2.3 moles. I hope that was helpful.